Greetings and welcome back. I want to give you in this video a very brief review / introduction to the reaction that is the acid-base reaction. Acid-base reactions are one of the first ones you learn about in general chemistry, and the reason for that is that they're one of the simplest reactions that we can possibly do. In an acid-base reaction, you are taking a hydrogen off of an acid and giving it to a base. So in general, we describe these like this. You have an acid, which we usually would write as AH, and you have a base, which we'll usually draw with a lone pair. The base uses its electrons and shares them with the hydrogen in order to make a new bond. The acid unshares electrons from the hydrogen, turning that bond into a new lone pair. You end up with somebody with a new lone pair, and what was the base will now have a new bond. And that's it. So to give you a couple quick examples, I would get off of the idea of using A and B really quickly and just think about it in terms of molecules. So we have sodium hydroxide, which is a very common molecule to use for this. Right, the sodium is off to the side, it's not doing anything, but essentially we have an O-, so that guy has electrons. It's got too many electrons, therefore it has some electrons it can share. And we'll put that guy in with HF. If you know what HF is, it's hydrofluoric acid. You know it's going to be the acid. It can share its electrons. So the way that this reaction can proceed is that the oxygen takes its extra electrons and shares them with that hydrogen. And then, therefore, you can't make two bonds to a hydrogen, so this pair of electrons that hydrogen was already sharing would become unshared and go to that fluorine. The result of this reaction would be that we would make now an oxygen with two bonds to hydrogen, which is, of course, water, and we would also have a fluorine with 4 lone pairs, which would be an F-. In this case, we can label these guys. The species or the reactant that gave away the hydrogen is the acid, and the one that shared electrons to get the hydrogen was the base. So the base is always, we sometimes talk about a base as being a proton acceptors. A proton is just an H+. You'll notice that you never actually have an H+ in here. You're just taking a hydrogen away without its electrons. So the base is the proton acceptor, and the acid is the proton donor. Those are kind of the terms that are used in Gen Chem, and they're still good here. But instead, I like to think about the base as being something that shares electrons with hydrogen. And the acid is something that unshares electrons from hydrogen. When we look at the products, we can refer to what we get on the other side, because these are reversible reactions, as the conjugate base and the conjugate acid. But realistically, this reaction could just go backwards. That F- could take this H back, and therefore that water would unshare electrons, and this could go in reverse as well. So sometimes these are referred to as, this guy would be the conjugate acid, and therefore that F- would be the conjugate base. Conjugate just means that they're paired up. So for instance, here's our fluorine right here. This is our acid, and therefore what we get afterwards is a conjugate base. This is our base, and therefore after it shares electrons, it can become the conjugate acid. But realistically, whether we use the term conjugate or not, in the backwards reaction, this guy would be acting like the base because it's the one that's sharing electrons with hydrogen. Notice it's sharing electrons with hydrogen. And this guy would be the acid because it's unsharing electrons from hydrogen. All right, so these are all terms that we'll use. This is a reaction we'll examine a lot, but it's a really good one to know. And so let's jump into the other videos.